Hello, today I would like to explain how we build a design radiator for cheap with no welding skills required. But let's start from the beginning. We had a space where chunky boring panel radiator was located and looked for something more exciting on a budget. As we didn't want to move the existing pipes coming out the floor and we wanted a high heat output, very flat radiator, it had to be a high wide radiator. These are rare as a rocking horse shit. And if you get them, the cheapest option to have something more eye-catching was £900 here in Britain. So we started off joining two cheap design radiators we got from a DIY store for less than £300, and we tried to fit them and join with more or less success. First was a screw fitting, which worked okay, but the water flow was only on the top section rather than on both, so not ideal, and it was leaky. And then we tried to brace, but bracing, there's too much material to brace, so it didn't really work and bond anything. And then I tried a local garage to see if they can weld it, but they didn't touch it at all. So in the end, I came across just by accident JB Weld bond, and I have to say I'm very impressed with the result, and the color just makes it even more amazing. Here you see an image of my remaining product of the two JB Weld components, the hardener and the bond itself. It's called steel. So I'm going to do a schematic which is not to scale. But basically here we have the top pipe of our radiator 1 and the bottom pipe of the radiator 1. And then we have all our smaller ones going this way. So that's one part of the radiator. Well, that's one of the smaller radiators. So then we have the other radiator here. Okay. And again we have our pipes going top to bottom. So here we have our inlet and here we have our outlet. Here's a cap and here's an end cap as well, and these are other parts open which I want to combine. So what I do is a screw thread . I have a screw thread and I screw in inside the cut open pipe joiners. Within the pipe joiners, and this is all glued in using JB Weld. Here you go. Within that I have a copper pipe which makes the whole thing flexible so the radiators can momentarily move in and out together and be apart. Okay. So this would be sliding, it would not be safe, but it gives flexibility to have the radiators move close together to test everything that it fits, pull them apart, put JB Weld on, and have this weld together as well. So the green part is the JB Weld, the golden one is a copper pipe, and the red ones are my cut brass pipe joiners, which are just, cut and made to fit. So that stage 1 should give enough rigidity, but we still have a slightly gap in there unsightly. So this one gets filled up, this whole area gets filled up with JB Weld as well, and then sanded down. So, and this basically gives us a complete connection. Water flows in, can flow down here. It can also flow down the smaller pipes up and down here and then out. This is such a compression pipe joiner cut in half and with a 50mm copper tube insert, and in my case a bracing trial. This is a fresh cut in half brass nipple, which is better than a pipe joiner. The insert will be screwed into the radiator. And that's why I recommend leaving the hexagon part on and cutting it in half. Once screwed into the one end of the first radiator half, the same type goes into the other radiator, which is to be joined together. It can then slide in and out for a good fit and hold well together with the JB Weld. So here you can see the weld now all fine in place and cured. This is just the inner weld. I will now sand down the parts as much as I can and then fill the gap with JB Weld so it all looks smooth like one piece of metal. So here you can see it all welded together now. All what's left to do is sand it down and then give it a few coats of paint. For the sanding, I use a soft sponge-like sanding block which forms quite nicely around the pipe and gives it a smooth feel. But I also use standard sandpaper for the corners sticking out a bit. There's one more tip I want to provide with regards to sanding. I use 120 grit sandpaper from a belt sander because it's got the strength to sand in between the pipes and to give it an extra smooth finish in the hard to reach areas. As I try to brace the radiators first, I have some bare bits of metal where the paint got braced off, which I had to sand, and I put some anti-rust coat underneath, some red oxide anti-rust. As you can see, each radiator has metal bars in the center of each to give it extra rigidity for the individual vertical pipes and the overall structure. They are not aligned well and I will not be altering or adding to them, as the design radiator will be held by 4 brackets on the top and a further 4 at the bottom. I will also not paint these vertical bars as they are offset and it may look odd. Color-wise, for our radiator, we choose a special radiator paint in Lamborghini Orange, bought from Paints for Trade here in the UK. This paint was available in gloss, satin and matte, with the latter we chose. This paint is quick drying, and while this is good, you will waste a lot of brushes and rollers, even with extra care as these get sticky and hard quickly, even in a sealed storage container. We found that a very short pile microfiber roller works the best. All painted and cured. Now mount all inlet and outlet pipework as well as the end caps. I'm using PTFA tape and give it 5 to 10 windings in clockwise direction so it turns itself tight when the pipe gets screwed into the radiator.
So the last thing is flushing the radiator. So I've got just a normal garden hose connected to one of the inlets, and it flushes out through all the other parts here as soon as the radiator is filled. Here we go, it gushes out the top and out the bottom as well, depending on if I close a hole by hand, hold it closed.
Thank you for watching, and here is the final result as our radiator is on the wall and heating up the room very nicely.